Assalamu alaikum wa rahmatullahi wa barakatuh. In this video, inshallah, we will start solving and explaining term 3 focused questions for the end of year exam 11 ASP. 8.1 subtopic 8.1. Okay. For the first question, now I'll try to give you time to stop the video and read the question so we can save the time of the video. So here the answer is D. Why? Because the strength of the magnetic field is depends on the density of the electric magnetic field lines. So as you can see here at region 1 and region 3, magnetic field lines are denser than other regions. So here and here, the density is the maximum. So that's why the strength of the magnetic field at these two regions is the maximum. Next question, we know that the magnetic field lines go out from the north into the south outside the magnet. So based on this, C is the right answer. It's from N to S. Again, please stop the video to read the question, okay? Now for this question, we have a current in a wire and we need to find the magnetic field at point B, which is 50 centimeter away from the wire. To calculate the magnitude of the magnetic fields, we can use this formula, B equal mu 0 times I over 2 by R. We need also to understand that all units here are SI units. So we can't use centimeter, we need to convert it into meter. For this problem only, we have this conversion to do. So B equal, mu 0 is a constant, which is 4 pi times 10 power negative 7 times I, which is 20, over 2 by R. R is 50 centimeter. That means 50 times 10 power negative 2 meters. The answer is B equal 8 times 10 power negative 6 Tesla. What is the direction of the magnetic field at this point? Of course, to find the direction, we need to use our right hand rule. And be careful, girls, please. When you are trying to find the direction, don't confuse between your hands. Yani sometimes students focus on which finger is which and the thumb is the current, etc. And they forget to use the right hand. So sometimes they use the left one. So be careful. Now, for this right hand rule, thumb is the current, and we try to catch, let's say, the wire by crawling our fingers. The fingers will give us the direction of the magnetic field. So below the wire, the magnetic field will be into the page. So into the page. Okay. Now, next question, we will use same formula to find the same thing, magnetic field strength. B equal mu 0 times I over 2 by R. B equal, the mu 0 is constant, so we will use the constant, which is 4 pi times 10 power negative 7 multiplied by I, which is 2.1 over the 2 pi times the distance, which is 3.5 centimeters, so times 10 power negative 2. The answer, using the calculator, of course, the answer will be 1.2 times 10 power negative 5 Tesla. So the answer is B. What is the direction? Now the thumb with the current, we are trying to crawl our fingers around the uh, wire. So above this wire, it will be up out of the page. So out of the page for this situation. Now also here we will use same formula to find the magnetic field strength. B equal mu 0 times I over 2 by R. That's equal 4 pi times 10 power negative 7 times 3.4 over 2 pi times 6.5 times 10 power negative 2. We also convert from centimeter to meter. B equal to, after using the calculator, it will be 1 times 10 power negative 5 Tesla. Now, so now our answer will be D or E, depending on the direction of the magnetic field. If the thumb is upward and trying to crawl our fingers, the magnetic field at the right side will be into the page. So the answer is D. Try it, please. Now, let's go to the next question. Magnetic field, we have a solenoid and we have the number of turns. Here I want to explain something. Let's write the formulas and then explain the idea. B equal mu times N times I. That's equal mu times N capital over L times I. I want to explain the let's say the difference between N small and N capital. N capital is the number of turns. L is the length of the wire in meter. N is number of turns per meter, so it will be turns per meter. And in the you need to understand the problem. Each problem has its own given. So in this case, they give us the turns and the length. Sometimes they will give us the turns per meter. So we need to know what do we have. If we have turns per meter, we will use mu times n small times I. If we have n like turns, n capital turns, and we have the length like this situation, we will use this formula because this one is the one with the one that will help us finding the answer. Right. Let's now calculate the current in the solenoid. Of course, again, we need to remember that we need to use SI unit. Micro Tesla means times 10 power negative 6. Okay? Always be careful. Now, B is given, so it's 50 times 10 power negative 6. That's equal to mu, which is 4 pi times 10 power negative 7. Number of turns is 2500 over length, which is 0.3 multiplied by I. Now, what is I? I is unknown. You can use now your calculator, shift solve or whatever. You will find that I equal to 4.77 times 10 power negative 3 ampere. Same situation here. We need to find the number of turns. So we will use B equal mu times N capital over L times I. We have B, we have mu, we have I, L. We need to find N. So let's try to substitute, but first millitesla. Millitesla is 10 power negative 3. So 0.65 times 10 power negative 3 equal to 4 pi times 10 power negative 7 times n unknown over L the length which is 3.8 multiplied by I the current which is 10. Shift solve and the answer will be 196. So n equal 196 turns. This is the okay. Now next question, question number 20. Also, I give you time to stop the video. Okay. Now in the solenoid, we need to know what are the factors that affecting the magnetic field strength. B equal mu n over L times I. This is our formula. Now, as you can see from the formula, there is no relation to the coil area. That's why it's not one of the factors, one of the factors that proportional. No. The current, yes. If the current increase, B will increase. So yes, the current is one of the factors. Number of turns in the coil. Yes, if the number of turns increase, B will also increase. So the answer is E. Okay. طيب, let's say what is the inversely proportional factor? Actually, it is L. If we are talking about inversely proportional, the length of the coil. Solenoid. Okay, that's it for 8.1. Inshallah, I'll make another video for 8.2.